Okay, so to get this idea of a limit at infinity, consider they give us this. It looks like that over here. It looks much better over here, way better. So let's look at it over here. And if you remember, the degree on the top and the degree on the bottom is the same. So that means I'm interested in the coefficient ratio. It's 1 over 2. And that's my horizontal asymptote. My horizontal asymptote is at y is equal to 1/2. Okay, and that's that dotted line down there. And you can see that when x is very close to 0, this x really doesn't matter. Well, I'm trying to circle it, but this x doesn't really matter. And if when x is really, really small, this looks really, really small as well, and that 1 looks huge. If 1 is over something infinitesimal, then the 1 looks pretty big. And you can see that up here, it's really big. And then as x gets bigger, suddenly, when x is 1, now it's equal to 1, because 1 plus 1 over 2 times 1 is 1. And then as x gets bigger and bigger, it starts to get closer and closer to my dotted line here. Oops. And the same thing in the other direction. What did I do there? 1/2. As x is very, very small and very, very negative, this doesn't matter at all, okay? And the 1 wins big, and the 2 is very, very tiny because it's being multiplied by something very tiny, but it is negative. So now we're down here, we're down here, very, very small, and also negative. But I mean, I said very small, in relation to positive numbers, big negative numbers. But anyway, down here, whatever you call this is very negative. So I guess you'd say big negative numbers. As the x gets a little bit bigger, as it goes out this way, the 2 catches up, and it starts to become the dominant force, and it starts to approach the horizontal asymptote from this side. And so hopefully that helps you think about it a little bit. I'm going to go through the same kind of thing down here. The definition of limits at infinity, as it's the limit as x approaches negative infinity of f of x is L sub 1, whatever that is. If it's the horizontal asymptote like up there, then there we go. And the limit as x approaches positive infinity, or just infinity, of f of x is L sub 2. Alright, so what does that mean? Well, we have an example. You can see that as x approaches positive infinity, this is going to get really big, and the 3, it may as well not even be there, okay? So as x gets huge, this just drops off and I have 4, okay? And you can see that is what happens. It goes up here and it gets really, really close to 4. It never quite gets to 4, but it gets really close. When x is really, really tiny, 3 is huge, okay? So like, for instance, if you have 3 over 1 over 1,000, well, that's equal to 3,000. So the 3 is really big, and the 4 is really tiny, and it's really, really negative. So it's way down here in the negative range. But then as x grows a little bit, the 4 takes over. And the bigger x gets, the closer to 4 it gets. And so anyway, that's what's going on here. And the same in the opposite direction. Same thing happens. So we come down here and we say, what is going on with this limit? Well, the limit as x gets huge, just unbelievable, as big as you want to make it, and then bigger still. Well, that 3 is going to be nothing, right? It's really going to be nothing. The limit is 0, okay? Oh, and by the way, just in case you were curious, rational functions, when the degree is bigger on the bottom, what's the horizontal asymptote? Well, the horizontal asymptote is the x-axis, which is x equals 0, so it is 0. But so either way you look at it, as x gets really big, the 3 no longer matters so much that you may as well just say the limit is 0, and that is what the limit is. It's 0. Okay.